When we want to create a formula for an ionic bond that includes an atypical cation, there's several steps that we're going to take. An example of when this might be the case is when we have something like iron 2 nitride. So we can tell that this is going to be atypical because iron is actually in the middle of our periodic table. So remember that the transition metals and then also tin and lead have some variation in how they oxidize. So they're going to have different charges. So I'm going to follow the same steps that I did with any ionic bond formula, and I'm going to find the cation's charge, I'm going to find the anion's charge, and then I'm going to crisscross those charges to get the formula. The problem might be, where are you coming up with these numbers? Well, again, because iron is in the middle of our periodic table, we can't just tell by looking at it what the charge of iron is going to be. Instead, this is something that has to be given to us in the name of an atypical bond. So we see this Roman numeral 2 right here, and that exactly translates to the charge of the cation. That's why I know that this is iron 2+. Now, as for the anion, nitrogen is a little bit more simple to predict its charge because it is in the 5th column, and therefore it is going to have a charge of 3-. So that's how I'm going to get my charges for my cation and my anion. And as usual, I'm going to take my cation's charge and drop it down to the subscript for my anion. And I'm going to take my anion charge and I'm going to drop it down as the subscript for my cation. So they are going to crisscross to create that formula.